All right. So thank you, Minoru and Tomoko, for putting on this symposium. I think is a really important symposium, as you mentioned, because of the problems happening with this particular species. So I'm gonna first just thank two people in particular that have contributed a lot to this presentation. One of them is a master's student working with me, Ben Lagbasi, who is pictured there on the ATV in the front. And the second is Emily Weiser, who provided a lot of the demography information that I'll present. But there's a lot of other contributors, both in the banding and the resiting and all the geolocator work. And these aren't all of them by any stretch. It was a very big project. So I'm just kind of the voice sharing all this information, but there's tons of people involved. So start my video. Okay. All right, so as Tomoko mentioned, there's at least 4 subspecies. See if I can get the little laser pointer going. Yeah, so there's 4 subspecies going down this flyway. Articula is the one that I'm interested in mostly because it breeds in Alaska, but there's also Socolina, Koschinskii, and Ectites that go all together down to this part of the world where it's pink. And then there's 2 other subspecies that I'm pointing out that breed in North America. The Hudsonica is on the far right, and the Pacifica that's in Western Alaska. Right. And they go different directions. Articula, as I said, goes this way, but the 2 subspecies in North America, the Pacifica and Hudsonica, go down this way. And that makes a difference, as you'll see in just a few minutes. Also note that there's big differences between these subspecies in terms of the population size. A lot of variability and unknown in terms of population size, but definitely these top 3 are much larger than this 4th one, Ectites, that breeds in the northern tip of Socolina Peninsula, and there's only 900 to 1,200 or so individuals. Okay. So what's happening with the Articula Dunlin that breed in northern Alaska? Well, we have several lines of evidence that suggest that they're not doing very well. One of them is a survey that we've done in northeastern Alaska, where this little red area is. That's in the Arctic National Wildlife Refuge, where we use these helicopters to access different areas of the ground, and we survey on the ground, and then we extrapolate our numbers to the whole area. And we did a survey like this back in 2002 and in 2004, excuse me, and this was kind of the data we got. Our point estimate was around 10,500 birds. We repeated that in 2019, and we estimated about 1/10 the number of birds were there in that year. Now, I say that with a word of caution because summers are getting earlier and more unpredictable in the Arctic, and it's really hard to time your surveys correctly. And I think we were a bit late that year, and some of the birds might have been incubating already. And if that's the case, they're harder to detect. And so this might be deflated a little bit from what it really is. So we were planning to redo that survey in 2020. We couldn't get there because of COVID-19. So now all of that is delayed until next summer. So we'll be able to confirm whether that major decline or apparent major decline is real. Another line of evidence is based on demography from the Arctic Shorebird Demographic Network, which has a lot of different sites collecting data on breeding ecology, basically. And Dunlin are listed here in the box. And annual survival for the Articula one, which is in the middle, is a lot lower than all the rest of the, not only Dunlin subspecies, but different sympatrically breeding species. And if you take that and put that into some population models, you'll see that population growth is much lower as well. And that has a lot of effect. If I can make it go to my next slide. Yeah, it doesn't want to advance. Sorry for the delay here. All right. So if you model or project that population growth rate out, we forecast that in 20 years, there will only be about 3% of the current population size, assuming there's no density dependence actions that are going to go forward. And all of this suggests to us, at least, that because only the Articula subspecies has this low survival rate, not the two other subspecies that breed in North America, which go different ways when they migrate, as well as the fact that all these sympatrically breeding species have higher survival rates. It suggests at least that some of the issues is happening away from the breeding grounds, somewhere either during migration or during the winter time. And so if we were to try to reverse these declines, I think the first thing that we'd want to ask is, where do these subspecies go, both in space and time? And once we figure that out, we could identify the threats that are occurring at those sites, and then we could prioritize management actions to try to change things. So a lot of what I'm going to talk about is trying to figure out where these subspecies go. The issue, though, is that they are not easy to tell apart by watching them or visually observing them. So as Tomoko mentioned, there's been a huge effort to capture and ban and then recite birds throughout the flyway in all of these different subspecies. And Ben's first chapter of his thesis, which just came out in Condor, tried to summarize all this data from the 1960 to 2017 era. And you can see all the number of birds banded of each of the subspecies on the top. We had to control a little bit and standardize things because some people were uniquely marking individual birds and other people were using cohort combinations. And so we standardized it that way so that an apple was an apple by comparing across the subspecies. And we also tried to eliminate any effects of site fidelity. So we're not counting the same birds over and over if they were seen multiple times. And what Ben then did was try to assign a resighting or a recovery to each of these flyway regions. So he broke the flyway up into these different zones. He looked at winter recoveries that occurred between December and February, and then migration recoveries, which are the rest of the year, but he did not separate the north and the south. And this is kind of the results we got. There were no recoveries of Koszczynskii. There was only about 50 birds banded initially, so it's not that surprising, I guess. But if you look at these maps, this is Socolina is panel A, Articula is panel B, and Ectides is panel C. The yellow dots are migration recoveries, and the blue is a winter recovery. And then the actual banding location is these little triangles, upside down triangles. So in Ectides, they were banded there, and then they were seen in this part of the world. And similarly, but the overall pattern was that if you look at during the migration period, Articula were seen, Articula is the one from Alaska, we're seen primarily in Japan. This is that pinkish color. And that was true both in migration and in the wintertime. In contrast, the Socolina and Ectides was seen primarily in the China Sea and the Yellow Sea. And same thing in the wintertime. So we see a somewhat of a spatial segregation, at least based on these banded observations. We also confirmed what Tomoko said earlier, was that there was a fair bit of annual site fidelity to particular wintering areas. And if you correct for mortality, roughly half the birds had some evidence that they were going back to the same site from year to year on the winter time. But based on our banding birds, the majority of that was just 1 to 2 years. But as you guys all probably realize, band recoveries have problems. They are snapshots of connectivity, although they do give you an exact location where the bird was. They are unable to determine how these non-breeding areas are interconnected because it's very seldom you see the same bird in more than one area. And I think the most important thing is that their non-systematic effort occurs. There's people not in areas where the birds are. And there's also people very well connected with internet in Japan, for example, that are able to report sightings of birds. So what you see from the band recoveries have some issues. So we then took the next step, which relied on geolocators to track the birds. And this was piggybacking on several other projects that were also occurring in Russia, and then a big effort to expand that to other areas. And Ben has actually done this throughout all of the circumpolar Arctic, but we're just talking today about the species that go down the East Asian Flyway. So he had a roughly 300 geolocators deployed between 2010 and 2017. 100 were recaptured so we could take the loggers off. And he has here, I'm presenting data from about 75 birds. And this is the deployment, well, actually the recovery data. We deployed at all these sites, but the numbers are how many birds were recaptured. So only 1 Actites right here, 5 Koszynskii, 32 Sokolina, and around 50 Articula. Doesn't want to advance again. Okay. So I'm going to show you a little bit how we went forward from here with Actites as an example, that one bird. You can see basically we can use 2 geos and FlightR to figure out roughly where the birds are, and then how long they stayed there is indicated by the size of the dot, and the color of the dot indicates what month they are. So this would be a winter time observations. These are more in the migration period. And this is where the bird was caught on the Sakhalin Peninsula. And the arrows, of course, or the lines just connect the dots. That doesn't mean that's how the birds flew. And these actually it's misrepresentative to say that that's exactly where the bird was. There is a fair bit of error around these things, sometimes hundreds of kilometers. So if you do that for all 75 birds, you end up with this. And it's kind of confusing and hard to make anything out of it. So Ben took another approach where he developed a migratory network. And to do that, he clustered stationary locations into these flyway regions. And the regions were actually much larger, bigger than you might want them to be. In this case, he limited it to, they had to be within 500 kilometers of each other. And then he looked at how they connected them, how birds flew between these regions. So I'm just going to show you an example with the south migration. Up in this corner here, the far upper left, this is birds migrating south. Each one of these dots and the numbers represents one of these nodes that he identified in this connection between going from the breeding grounds to the wintering grounds. And then this is more grammatically showing how they're doing it with the red or the pink, orange dots here, birds actually moving south during migration. And then the blue is when they're actually reaching the wintering time. But this is all during south migration. And essentially what we find, and you can do this for every one of these little nodes, all 15 nodes, you can display how the birds spent time, how the different subspecies spent time at that node. And so in this case, the green is Articula, They were there mostly in September on the second node, which is in Western Alaska. And then no other subspecies was present at that second node. And you can do that for all of them. And what we generally find is supporting some things we saw during the banding. Only the articula were in Alaska staging, and they also used the number 10 site here for migrating south. The Socolina were in the S7, the 7 through 9 area, and then spent a lot of time in the Yellow Sea primarily. So he also, from putting it all together like this, you can compare when birds are using, when the different subspecies are using the same area. And he discovered that Koszczynskii, coming from this part of the world, are migrating first, then Socolina, and finally the articula. So he did that for the wintertime as well. Again, found 15 regions where they were during the wintertime. And his conclusions are that articula are primarily in central Japan, which is the number 2 site on the map here. Right there, I guess it is. He found that Socolina, again, is mostly in the Yellow Sea and the China Sea. But then a lot of the regions supported all of the subspecies. He did also find that Koszczynskii, probably because they migrated earlier, spent a lot more time on the wintering grounds than the other 2. And finally, during northward migration, there was less differentiation. The species seemed to move together both spatially and temporally. And Sakhalin Peninsula, number 2 over here, supported a lot of the subspecies, all 4 of them. And the Sea of Okhotsk had many important stopover sites as well. So what I conclude from a lot of this is, if you put it all together, we don't have much information for Koszczynskii or Actites. And Actites, where they're going. We have a little bit of data from both banding and the one geolocator bird of them using the Yellow Sea, but we don't know if they are using more restrictive areas or if they're just generally moving around. Again, articula are in Japan, and Socolina are more in the China and Yellow Seas. There's a little bit of differences in migration timing. But I think another major conclusion we get from all this is that you can't rely on a single area to save a single subspecies. There's many areas that are important to all of these subspecies. But geolocators have issues too. They have very poor accuracy. You only get data from those individuals that are surviving. So if you have individuals going to areas that are problematic, you never hear about it. You never get that information. And so that is a real issue that could be playing into this. We only recovered at 30% of our birds that we initially tagged. So the other 70% are either immigrating somewhere else or dying. And even though we had a huge effort to do this, in the end, we had about 75 birds belonging to all these subspecies. So when there's potentially 300,000 or 3 million birds, or whatever you add up all those numbers, 75 birds is very low. There are some new technologies, and I just want to show you something, an effort we made to do using these backpack GPS archival tags. They're very similar to geolocators in the sense that you have to catch the bird again and download the data, but they do give you GPS level accuracy, and they give you fewer locations. In this case, we programmed them to give us a single location from the 20th of June to the 16th of October when the birds were migrating. And then we turned them on again in December to February for a period of time. And out of 57 tags that we put out, we only recovered 6. So this is a telltale thing that using a leg loop harness on a Dunlin is not a very good thing to do. Very, very few came back. And that is a much lower return rate than what we had from our banded birds. We did see a few birds that had lost their tags, but generally we just didn't get very many back. It gives you much better data. As you can see here, this is step function of latitude when birds are leaving relative to time. And this little line here is when we had shut off the tag. The reason we shut them off is because they're battery operated and you would have ran the battery down before they got to the wintering times. But you can see we had a couple birds go to China and actually spend some time there, and I'll show you data in just a second. One bird went to Sakhalin Island. We had another bird that ended up stopping, collecting data there, and another one right there. And if you go to the next thing, the other beauty of this is we know exactly where they went, and we know they're not just spending time on the intertidal area, but they're also spending time inland. So these little GPS archival tags are a good thing if you can make them work and stay on the bird and not affect the bird. So a couple things that really come to my mind is where we want to go is we need to have, at least from my selfish perspective in Alaska, given that we think most of the birds go to Japan, the articulate birds, is there something happening in Japan that we don't know about? And all the survival data I presented is also starting from 2010, going to about a 5-year period. So it overlaps really nicely with what Japan collected in terms of their monitoring. There seems to be a real something happening in that period of time, this last decade. We also, of course, know where Dunlin are on the ground. People are surveying Dunlin all the time. So we could catch birds and we could use genetics and morphology to try to differentiate the subspecies. And that is occurring a little bit. I know Tomoko mentioned it, that they're using genetics. And I've also heard of a site in China trying to do that. But I think the important thing to also remember is that we have to keep building and updating these migration connections because the birds are adapting to this changing environment. And what I showed you now may not be true a few years from now. And finally, we need to take advantage of new technology as it becomes available. And it is becoming more and more available all the time. New tags are coming out. So with that, I'd like to stop and just thank the funding sources, but there were many, many, many funding sources.